So hello everyone, my name is Mia. I'm very excited to be here. So this is my first time in Wales, and also this is my first time at PyCon UK. And I have to say that I have visited many PyCons, but I have never seen such a beautiful venue. And I have definitely never spoken in such a beautiful room. So I also want to thank organizers for all of their efforts, and I'm very happy to be here. So my talk today is about Python standard libraries. So I would like to welcome you to the standard library tour. But first, let me introduce you myself. I work as a software engineer at Atacama. Atacama is a Canadian Czech company that specializes in creating data products. I have over 5 years of experience in the IT industry, and I try different things from tech support, testing, analysis, and software development. I'm based in Prague, Czech Republic. I'm organizer of Prague Python meetups, PIVO. I'm also organizer of Czech PyCon conference, and this year I also organize EuroPython. So what does it mean? It means that if you're in Prague, drop me a line. I would love to meet. If you want to attend our events, if you want to speak, or just to meet with fellow Pythonistas, drop me a line. I would love to meet. Also, we have a stand here, EuroPython Society, in case you would like to learn more about EuroPython, maybe to visit our conference if you need Fin aid, or if you're a conference organizer, just go there. We are in the hall, and we would love to talk. So, I guess that most of you are probably familiar with the standard library, but just to ensure that we're all on the same page, so let me just quickly mention what is the standard library. So it's a collection of modules and functions which are included with Python. It offers numerous functionalities without having to install third-party libraries. And these functionalities include things like interacting with operating system, running servers, scientific computing, debugging, data manipulation, and many, many more. So now you might be wondering, but why should you know anything about the library? I mean, why should you even care? Why are you even sitting at this talk if you can just re-implement the features by yourself? So if you use the library, you're not reinventing the wheel when it comes to finding solutions. These solutions that are there are already optimized for efficiency, and by using these solutions, you can help avoid many bugs that have already been fixed. So just to manage the expectations, let me just mention what is this talk about. So it is a brief overview of lesser-known features of the standard library, and the aim is just to discover the unknowns meaning the features that probably you didn't know that exist. So I was thinking a lot about what to talk about, because the library is obviously huge, and I could be here talking about it the whole day. So I started thinking in 2 dimensions. So which models are well-known, meaning that you probably might have used it, or you will probably use it in the future, but also which things are well-known, some things that we do on a daily basis as developers, things like, for example, testing or documentation or something similar. So what I will not focus on is less-known modules. We do some less-known things because that's a topic for some niche, small audience. And I also don't want to focus on top 5 functionalities of the standard library, because you can just Google it out. Instead, I would like to focus on the other 2 quadrants. So we can start with the first one, which is well-known modules, which do less-known things. So we can see what is hidden in the modules, which all of you who have already used the standard library have probably used. Just a small disclaimer before we start. Whether to use the standard library or not, it depends on your specific use case. All the code examples are just illustrative, so you would be able to understand it and not to have to think about the code itself. So functools. Raise your hand if you have ever used functools. Okay, lots of people. So functools is one of the most frequently used models inside the standard library, and it offers a variety of tools for working with functions. So things like modifying function behavior, maybe creating some other function like objects. So let's start with an example. We have a function which adds 2 integers together, and which adds 2 things together. So it should handle both inputs, integers and strings. And in case their integers are given, then the function should add them together. And in case there are strings, then it should concatenate them with an empty space in between. So you could write something like this, for example. And if we run it, we see that it works as expected. But there might be a better approach on how to solve this problem. So here we have a single dispatch decorator above the function add. Then we specify for each type in a separate function. So if user enters integers, the function defined on the line 10 is run, and that one adds integers together. And if user enters strings, then the function on the line 15 is run. And for all other cases, the value error on the line 6 is returned. So single dispatch decorator, it's used for function overloading. Function overloading means creating several methods with the same name which differ from each other in the type of input parameters or the number of input parameters. And it's commonly used in cases where you work with different data types as inputs to your functions and you don't know what kind of data types are your inputs. So for example, you're parsing data from some file and you don't know if there would be integers or there would be strings. So now you might be wondering, but why to use single dispatch instead of just having if, else, if, like in the first case, because both of these are functional. So if you use single dispatch, it's easier to modify, meaning that you have each function that handles only one type. These functions are independent, and they can be independently modified. Also, the code is cleaner, more readable, and it's easier to test it. However, it dispatches only for the first argument, so that means that there's a downside, and that is if there are multiple arguments that you would have to use a third-party library. So let's check some more examples of the hidden gaps in the functools module. So let's say we have a function that adds two numbers together, but very often we add by 2 only. So you might write something like this, where you define the default parameter. Now, what if you need to add by 3? So then you create another function. So basically, you're just duplicating the code. So instead, you could use partial. So in this case, we've defined a function named add, which acts as some sort of a template for 2 other functions, add to 2 and add to 3. And we use partial to pass add into these functions where we define argument in each case. So in this case, we have the core logic, which is kept at one place, that's line 4 and 5, and then we have multiple partial functions that are able to reuse that code. So if we run it, we see that it returns the correct result. So partial is used to create a new function with some sort of the arguments of the original function, so some sort of template you can imagine. And it can be used with any kind of callables, so built-in functions, methods, arrays, or quarks. So now you might be wondering, but what is the advantage, or why should I use it instead of just using the default parameters when it works? So the main advantage is code reusability. So basically, you're adhering to the principle of dry, don't repeat yourself. And the common case when you use it is when you need to call a function with the same argument multiple times. So I've seen it in production, actually, in a case where you have a function which calls various API endpoints, and for each API endpoint, you have to pass authentication headers. So, for example, you don't want to pass the header at each place, because in case the header changes, then you would have to edit each of these functions. So in that case, you have one function, then you have other ones which basically reuse the first one, and you have all the logic at one place. It has its own downsides, like everything. The downside is that it might not be intuitive for new Python developers. So for example, if your team is very junior, or they have a different background, they come from a different programming language that doesn't have partial functions, then maybe you would want to sacrifice reusability for better readability. Now let's see some more examples from partials. So we have this Fibonacci function. This function is recursive and also does some sort of, let's say, expansive operations. So how can we improve it and make it faster and more efficient by using the standard library? So one option is we can use LRO cache decorator from functools. So this decorator essentially caches the result returned by the function. So in this case, the function doesn't need to execute the code every time. It can return the cache results instead when they are available. And from version 3.9, we can also use the cache decorator. So least recently used decorator stores the results of function calls. It checks for the key in cache dictionary. When the key is present, the wrapper returns the value and updates the cache hit info. And if the key is missing, then the wrapper calls the user function with pass arguments, updates the cache, and returns the result. In case the cache is full, then LRO cache evicts the old items and adds new ones. So now you might be wondering, well, is there any difference between LRO cache and cache? So cache is available only from version 3.9, and it is basically the same as LRO cache, where we define max size as none. And it doesn't evict the old values, so it's faster. So I tried to do some benchmarks, just to mention that this is not a precise method. The results vary across runs and machines, but for now we can just focus on ratios, which are typically consistent. So this is just for like some rough comparisons. So we have 3 examples: Fibonacci function without caching, with caching, LRO cache, and cache only. And you can notice that the cache versions are noticeably faster, indicating that caching obviously speeds up our code. And you can also notice that the performance of LRO cache and cache versions is approximately the same. All right, so let's move to another well-known module. Raise your hand if you have ever used Itertools. Okay, so Itertools provide various functions that create iterators for efficient looping, and they're useful when you're handling large data streams. So let's start with an example again. Let's say I need to calculate the Cartesian product of 2 lists. So here we see that we have 2 lists, and we have 2 nested for loops where we iterate over both lists, and basically we have the results that we want. But instead of calculating it by ourselves in that way, we could use instead Itertools.product. And as you can see, it returns the same results. So basically it returns the Cartesian product of 2 iterables. Let's see some more examples. Let's say I have a list and I want to filter elements that are in another list. So we can use the built-in function filter, which does exactly that. And now you might be wondering, but what if we want to do the opposite? Can we do something like not filter? So when we want to filter elements which are not in the list, so we can call Itertools to the rescue. We can use filterfalse, which is exactly the opposite of the built-in filter. So filterfalse, it filters elements from an iterable, returning only those for which the predicate is false, and it is the opposite of the built-in filter. Let's see some more examples with Python's built-in functions. So we have 2 lists, and let's say we want to combine them together. What you can notice here is that the first list contains of 3 elements, while the second one contains of 6 of them. So what does it happen when this code is run? When this code is run, only the first 3 elements are merged together. Why? Because it doesn't take the elements for which there is no value in the first list. So basically, it just discards them. But what if we want to have all the elements zipped and we want to fill some arbitrary value in case there are no elements in the first list, for example, none? So we could use the zip longest function. Basically, it works in a way that it fills the value for the missing elements, and we can also set up our own value, which we want to have there. So for example, in this case, it's none, but it could be any. So far we have talked about functools and Itertools, and I would like to talk about one more well-known module, which is also commonly used and has some interesting hidden features. Collections. How many of you have ever used them? Okay, so let's say I have multiple dictionaries and I need to find some key here. So we could do something like this. But what happens if I don't have only 2, but I have 10 of them? So that means that our if-else-if statement basically would grow. And while this is fully functional, it might not be the best approach. So let's see if we can improve it maybe a bit with a standard library. So we could use ChainMap. Here we add all dictionaries to the ChainMap class, and it groups all the dictionaries together. So basically, when you're searching for a key in the ChainMap, it will search for it in all group dictionaries, and it will return you the first result it finds. And now you might be wondering, and how about creating a new dictionary and using the update method to add all the data, because this is also functional, and in this way we could also group all dictionaries into one and then iterate over it. So the difference is that ChainMap references already existing dictionaries and doesn't copy any data, while the update method does, and that's why it's more efficient. So basically, it groups multiple dictionaries into one, and it provides a single dynamic view. And when one of the dictionaries gets updated, the update is visible in ChainMap as well. So speaking of dictionaries, what happens when we attempt to search for a key that doesn't exist? The key error happens. And is there anything we could use from the collection model to prevent the key error? So it happens that collection have a subclass of the dictionary class that returns a dictionary-like object, which is defaultdict. So the difference is, however, that we can use it also with non-existing keys, and it doesn't return the key error. So instead, it just supplies the missing values with a value that was passed, and in this case, we instruct it to supply the missing values with a none value. And if we run it and try to access value for the key that doesn't exist yet in the dictionary, we can see that it returns as none. So defaultdict, it is a container-like dictionary that returns a default value for a non-existing key. It is commonly used for grouping or counting elements in a collection, and it can make code simpler and more readable by eliminating the need to check if a key is already present in the dictionary before doing operations on it. And now you might be wondering, but what if my structure is nested dictionaries? Can I still use it? Yes, you can. You can have multiple nested dicts with the defaultdict as well. All right, so let's now move to the second part. So less known modules which do well-known things. These things are things that we as developers use on a daily basis, for which there might be tools in the library, and knowing about them might be useful. So I will not ask you how many of you write tests, because I hope all of you do. There are certain frameworks for writing tests, for testing APIs, web application, and you can find lots of materials on the internet about testing. However, I would like to focus today on a less explored topic, and it's this quick and dirty kind of testing without using any frameworks. So let's say you have a small script that calculates something. This is not inside some big code base. This is not a corporate application where you have proper tests and frameworks and everything, but just some small script you might run on your PC every day, and let's say it's important for you, and sometimes you do change something, and ideally you would want to have there some documentation as well. So I discovered the doctest model. So basically it works in a way that you add some examples in the docstring, which are both tests and documentation for your script. So if we run this, we see that nothing happens, which is normal because there are no errors in our examples. But let's say we change our test. So notice here on the line 10 that we changed it from -15 to 15, and if we run it again, we can see that our test failed. Expected 15 got -15. So test mode is used for very simple scenarios, mostly for quick and dirty kind of testing and documenting simple scenarios, very small scripts. These test cases are readable to humans, so it allows you to test and to document your code in the same time. Comparing different things, it's also something we very often do, or at least I often do it, and it happens that in the standard library, there's lots of different tools that can be used, which are not that well known. So let's see some examples. Here we have two strings, and let's say we want to compare if they're the same, and if not, we want to determine how different they are. So to compare sequences, we could use the difflib. Here we create an instance of the differ class, and we compare to strings. So when we print the result, we can see that all the characters are the same, except of the one on the line 8, which is missing in the second sequence, and the one on the line 9, which appears to be in the second sequence, but it's not in the first one. And we can also calculate the ratio of comparison between these two sequences. In other words, how similar or how different our sequences are. And here we can see the result. 91% means they're very similar. So difflib, it's used for comparing pairs of sequences of any type, string, tuples, lists, anything, as long as sequence elements are hashable. And it uses the Radcliffe-Obershef algorithm, which you can read something about if you're interested in that. And with difflib ratio, we can measure the similarity between the sequences, where the values are between 0 and 1, no match and identical match. And usually the ratio over 0.6 means that the sequences are close matches. So those were sequences, but how about other things we work with every day? For example, files. Can we compare the contents of two files? Yes, we can. So there is a model for that in the standard library as well. So here we have two files, and let's say we want to compare them. So we can call the CMP function from the file CMP module. And here, when we compare it, we can see that the files are equal. It returns as true. That means that the file type, size, modification time, and content are identical. That was file, but how about directories? Can we compare them as well? Yes, for directories, there's a method dircmp, which compares two directories. And when we call the report method, we can see the difference. So here we can see that the file 1 is only in directory 1, while the file 2 is in the directory 2. So file CMP defines functions to compare files. The dir CMP class constructs a new directory comparison object to compare to directories and provides multiple functions to define what to compare and how to show the results. And it's useful for cases, for example, where we have different versions of the same project. And the last great feature from the standard library I would like to talk about is the context manager. So let's see an example. Let's say we have a file which we need to open, we want to do something with it, and then at the end we need to close it. So for this, we could use the context manager decorator, where we write a function, we define our operation that is supposed to happen at the beginning before we use it somewhere else, and at the end after we have finished our work, and then we use the with statement to use it. So if we run this example, we can see that first we opened the file, then we wrote to the file, which was an operation inside the with statements, and at the end we closed the file. So context manager defines a factory function for with statement context. It provides a clean, easy to read way to manage resources that need some setup and tear down phases. And you can ask multiple context managers with blocks to use them at once or using a single with statement by separating them with commas. It's used for opening and closing files. You can use the built-in open, but it's used commonly for things like acquiring and releasing a lock, working with network connections, temporary files, changing and restoring global settings. And now you might be wondering, but what if my function is async? Does it work in the async context as well? The answer is yes and no. It doesn't, but there's another decorator for it in the library as well. So if your function is async, then you can use the async context manager, and here is exactly the same example, but only async. So here is our main function where we run it, and we can see that it behaves exactly the same, but only difference is that the one is intended to be used in the sync context, while the second one in the async. All right, so we have covered the second part where we talked about less known modules which can help us with everyday things we developers do. And at the end, I have 2 takeaways which I would like you to take out of this talk, because you will probably not remember all of these examples. There was lots of code here, and you will probably not remember all of these details, and that's perfectly fine. But I would like you to remember the following. The first is the standard library is packed with very powerful tools, and the second is always verify if there's an existing tool for your task and if it suits your needs before attempting to create something from scratch. I hope you enjoyed the talk and it has inspired you to embark your own journey of exploring the standard library. Thank you very much for your attention.
We have time for one question. Anyone, please?
At the start, you said the stuff that you were going to touch on is stuff that we don't know, I was asking if you have a preferred method, sorry, I'll speak up, a preferred method of finding these niche tools, because if a room of specifically Python developers isn't going to know it, then it's probably not going to show up in the first result. I wonder if is documentation just the best and only way?
So I think the best way how to find about it is when you're solving a problem where you could use it. So for example, for me, what helped me a lot to discover a lot of these great tools is advent of code, or in general, solving some programming puzzles, because very often you will need there some tools and a bit more of algorithmic thinking than maybe you would need at your job where you are working maybe with data science or APIs or something similar. So I would really recommend something like that. And also giving a talk is a great way to learn something. So if you would want to, I would warmly recommend you to also give a talk about some topic. And of course, just going to conferences and listening to other people's talks and, just getting inspired about all the great things that are there which you could use.